Okay, increments, part 2. Here's where increments, part 2. Here's where just when you think you got it, just when you think it's easy, it's going to get complicated. All right. The problem with doing these increments with these problems is you're not going to be given, you're not going to know. Here's my y-axis. Here's my x-axis. The problem is that you're not going to start with the first increment. You're not going to know that. You're not going to know what. Once I know the first one, I can count and add by the first one. But what's going to happen is you're only going to know the fourth one, or this. See, we're breaking up one cycle for these graphs into four, right? So what I do is I put a mark here, and then I go half of that. I put a mark there, half of it, right? Right, make sure it looks even, and then I do half of this, and see, now I go half of here, and I go half of here, and I get 4. 1, 2, 3, 4. Okay, so I'm going by halves. Pay attention, I'm going by halves. I just mark it here, I mark off just somewhere over here, and then I do half of that, and then I do half of that, and then half in between here, right? I got 1, 2, 3, 4. Again, so the problem is you're not going to be given this one. The problem is the only thing you're going to get from the equation, from the function, is the period, which is how long it takes it to complete one cycle. The length it takes for the graph to complete one cycle is what you're going to be given, not the first one. So the question is, how do you find these? Like, what are these going to be? Is this going to be 2, 4, 6, 8? Nope, can't be 2, 4, 6, 8. Okay, so let me tell you how you're going to do it. Exactly what you saw me do. When I had this, I got half of this. I made the halfway mark. So I got 10, whatever this number is, divided by 2. Is 10 divided by 2 possible? Yes. I got half of it, right? Because this is the whole thing, I took half of it. So 10 divided by 2, that means this one's 5, right? Because this is the halfway mark of this. I go in half of that, 5. And now, for this distance, I'm taking 5 of this number. When you take half of a number, you divide it by 2. Well, if it's an even number, you'll get an answer. If it's an odd number, 5 divided by 2, we don't want fractions. I'm sorry, we don't want decimals. 5 divided by 2, yes, it's 2.5, it's 2.5. But if it's not an even number and it'll divide and give you a nice number, just leave it like that. What's half of 5? Well, whatever 5 divided by 2 is. Just leave it as a fraction. Okay? So now you know, right? We're trying to break it down to get to this one, to the first one, because now, once I got this first one, I know what I'm counting by. Here, now I know that my increments are what? Increments of what? Of 5 halves. So I'm counting by 5 over 2. 5 over 2 plus another 5 over 2 is 10 over 2. I got this one, I got this one, and see, now you got to count up. Now you got to find this one and then count up to get this one here. This is the only missing one. So again, we started with 10. We didn't know these. We started with 10. You came here to half of 10. Half of 10 is 5. And then you went another half and you got half of 5, and that's 5 over 2. This is the one you want. This is the one you need. Because now I'm going to count by 5 over 2. 5 over 2 plus another 5 over 2. The next one's not 6. You're going by 5s. The denominator stays. You're adding by 5s. 5 over 2 plus another 5 over 2 is 10 over 2. 10 over 2 plus another 5 over 2 is what? 15 over 2. Right? You're just adding a 5. This number's telling you you're counting by 5s. Add another 5, 10. Add another 5, 15. Add another 5 just to check if this is right. What's 15 over 2 plus another 5? Wouldn't that be 20 over 2? Of course it would be 20 over 2, and then 20 over 2 is 10. So these numbers are the correct increments. Okay, let's do some more. Again, we're not starting with this one, but we're going to break it down to get this one and then go forward. You're starting with the last one, actually. Okay. So let me make a mark out there, and let's say that again, this will be the length it takes for the curve to make one cycle. I'm just going to make a mark out here. I'm going to say that this is 6. And then I know I have to break this into fourths. If I just do this, that's not fourths, that's just 2 of them. So I got to break it in half, and then when I break these in halves, I'll get 4s, right? I'll make this in red. See, I'll go half there, and I'll go half there. All right. So then if I went here, what's the half of 6? Well, divided by 2. 6 divided by 2, well then this is what? 3. This one's 3. And then now to find this one, it's half of this. What's half of 3? Well, whatever 3 divided by 2 is. It doesn't divide evenly. Leave it alone. 3 over 2 doesn't. It gives me 1.5. Just leave it. 6 divided by 2 does give me a nice whole number. That's why I reduce it to 3. But when this doesn't reduce nicely, just leave it. Leave it as a fraction. But the point is to get this one. The point is to find the first one. What increment are you counting by? See, you started with this, then you took half, you got this, but now you got to count up to get this one. So you got to count up to get this one. So what are we counting by here? 3 over 2. You're counting by 3 over 2. So here's your increment. So 3 over 2 plus another 3. Remember, you're adding by 3's on the top. That's a 6. And 6 over 2 plus another 3 over 2. Well, 6 plus 3, 9 over 2. And can you reduce that? No. And if I check and I add another 3 to the 9, that'll be 12, right? 9 plus 3 would be 12. And then sure enough, 12 over 2 is 6. So I know it's good. So these are the correct increments, and I'm going to be checking that. Always look to reduce. Okay, keep going. Let's practice some more. Now you're going to get some fractions. You're going to get some radians, so I'm going to go there. Okay? Let's do one more whole number, because this one's going to be a nice one. What if I tell you 3? What if I tell you 3 is the period? I got to graph one cycle in this length, and I need to have 4 sections, 4 increments. So I'm going to take half of that. I'll go right there, half. And then I'm going to go half of here, and I go half of here. All right, what is half of 3, right? This is the halfway mark for 3. What's half of 3? Well, 3 divided by 2. 3 divided by 2 does not reduce. Okay, now what's half of 3 over 2, right? Well, remember, when you take half of something, what's happening? You're dividing whatever it is, and you're dividing by 2. Where does the 2 go? When you take half of something, the 2 goes in the bottom in the denominator. But when you already have a fraction, when you already have a denominator, 3 over 2, and you're going to divide it by 2, well, there's already a number down here. Since you know the 2 goes on the bottom, you just multiply that 2. Right? When you divide by 2, you get a 2 in the bottom. This one already has a 2 in the bottom. But if I'm taking half of 3 over 2 and multiply 2 to the denominator, half of 3 over 2, believe it or not, is 3 over 4. Right? 2 times 2 is 4. Leave the 3 alone. Leave the numerator alone. When you divide something by 2, you put a 2 in the bottom. But if it's already a fraction, just multiply the bottom number by 2. So half of 3 over 2 is 3 over 4. And now I got my increment. That means that if I count by 3 over 4, all of these should fit nicely. Let's see. Let's pretend I don't have these. If I'm counting by 3 over 4, the next one would be 3 plus 3, 6 over 4. And then another 3, add a 3 here, right? The denominator stays. 3, add by 3, 6, add by 3, 9 over 4, add by 3, 12 over 4. Well, let's see if this is right. Is it true that 6 over 4, when I reduce it, gives you 3 over 2? Yes. This one's right. This one's right. So you got to look to reduce. And then 9 over 4. Can 9 over 4 be reduced? No, it can't. So it stays at 9 over 4. And what is 12 divided by 4? 3. See, it checks out. It works. All right, let's keep doing some more. Okay, so now, what if your period is this distance that we're going to be using to graph one cycle is 2/3. It's called the period. The length and the amount of time it takes to complete one cycle. Well, I got to find the halfway mark of 2 over 3 first. Again, how do you take half of anything? You put a 2 in the bottom. And if there's already a number in the bottom, you multiply that number by 2. Half of 2 over 3 is 2 over 6. Half of 2 over 3 is 2 over 6. But before you go half again, look at this. You can reduce 2 over 6. So really, 2 over 6 is what? 1/3, right? Divided by 2. Well, doesn't it make sense that half of 2 over 3 is 1 over 3? Yeah. Half of 2/3 is 1/3, right? 1/3 plus 1/3 is 2/3. Oh yeah, of course. Okay. Now I got to get this mark, this increment. I'm 1/3. How do I take half of 1/3? Half of 1/3, that means that the 2 goes in the bottom. I multiply by 2. Half of 1/3 is, if I take half of this and the 2 gets to the bottom, you multiply, you get 1/6. Half of 1/3 is 1/6. There's your increment. That means I'm counting by 1/6. I'm going to go ahead and, I forgot to make this mark. I'm going to count by 1/6 up here, and you'll see that all these are going to make sense. If I'm counting by 1/6, my increment is 1/6. What's the next increment if I'm going by 1/6? Well, 2 over 6. Oh yeah, of course, we did that right there. It is 2 over 6. We reduced it already. What's the next one after 2 over 6? 3 over 6. And what's the next one after 3 over 6? 4 over 6, right? On this one, we're counting by ones. 1, 6, 2, 6, 3, 6, 4, 6. All right. So this is good. This is good. 3 over 6 will reduce to what? 1/2. And if 4 over 6 is this, I did this right. Is 4 over 6, when you reduce, give you 2/3? Yeah, that means this is correct. This looks great when you see it. See, 1, 6, 2, 6, 3, 6, 4, 6. And it looks right. But when you see 1/6, 1/3, 1/2, 2/3, that doesn't look right. It doesn't look right. It doesn't look like you're counting right. But in actuality, look, you are. 1, 6, 2, 6, 3, 6, 4, 6. But when I reduce these 3 and they become this, it just doesn't look right, but it is. It is. Okay? All right, let's go into radians. What if I tell you that your period is pi? Well, I got to go half of that. Now remember, pi is the same as, what number is here? Well, it's like x or whatever. It's 1 pi. This is a 1. It's a 1 right there. How do you take half of 1 pi? Well, it's going to be pi over 2, or 1/2 pi. You can put a 1 if you want, if it makes you feel better. It's 1/2 pi. And then you take half of that, and then you take half of that. So pi over 2 is the same as, remember, just leave the pi, just look at the fraction. Pi over 2 is the same as 1/2 pi. And how do you take half of 1/2? Remember, how do you take half of anything? You put a 2 in the bottom, and if it already has a fraction, if it's a fraction that has a number down here, multiply. Half of 1/2 is 1/4. So this is going to be 1/4 pi. 1/4 pi, which is the same as what? Pi over 4. That's your increment. Your increments are in pi over 4. That's the one you need to get. And when I count by pi over 4s, all these are going to sit right, and you'll find the third one. So it'll be 1/4 pi. It'll be 2, am I counting by ones? Yeah. 2/4 pi, 3/4 pi, and 4 over 4 pi. If this gives me this, I know it's right. Of course, 4 divided by 4 is 1. So I know this is right. Of course, 2 divided by 4 is 1/2. I know this is right. So that means that this one is what? 3 pi over 4. It cannot be reduced. So these are your increments. Okay, last one. Two pi over 5. 2 pi over 5. I want to get here to the halfway mark here. This is the whole thing, so it would be half of 2 pi over 5. Well, 2 pi over 5, and I'm taking half, that means you multiply the bottom by 2. And then you can either cancel the 2's, or you can do 2 pi over 10, and you'll still get 1/5. It's still going to reduce to 1/5 pi. 1/5 pi, or pi over 5. Pi over 5. What is half of pi over 5? Well, if I take half, that means that 2 goes here. 5 times 2, this is going to be pi over 10. That means your increments, each one of these is counting by what? Pi over 10 is the same as 1/10 pi. You're counting by the fraction 1/10. 1/10. What's the next one? 2/10 pi. What's the next one? 3/10 pi. And 4/10 pi. Now, if this reduces to this, and this reduces to this, we're doing it right. Does 2 divided by 10 give you 1/5? Yes, it's correct. This is correct. This is correct. Does 4 over 10 reduce to 2 over 5? Yes, it is. It's correct. So that means that this third one is 3 pi over 10, and you can't reduce it, so it's 3 pi over 10. All right, make sure you're experts at this. This is not too difficult. All right, that's it.